Assalamualaikum and hello everyone. In this video, I am Qaisara Aqilah from class M1T2 batch 2024-2025 will demonstrate to you on how to solve question number 1 from PRE-PSPM KMK set 2, chapter 1. So let's get started. Let us see the first question. Naturally occurring argon consists of 3 isotopes: argon-36, argon-38, and argon-40 in the ratio of 4.86 to 1 to 1,423. The first question is asking us to calculate the percentage composition of the 3 isotopes. As I already highlighted in the question, percentage composition refers to percentage of abundance. So we need to calculate the percentage of abundance for the 3 isotopes that which is argon-36, argon-38, and argon-40. So we need to calculate one by one. So first, let us start with argon-36. So the question has already given us the ratio, which is the relative abundance for each of the argons. So the first is argon-36. So the relative abundance for argon-36 is 4.86. So we need to apply the formula of percentage abundance. So we need to use the relative abundance of argon-36, which is 4.86 divided by the total of relative abundance of the 3 isotopes, which is 4.86 plus 1 plus 1,423. And we need to multiply by 100 to get the percentage. So the answer is 0.34%. And next, we need to calculate the percentage abundance for argon-38. So the ratio given for the relative abundance of argon-38 is 1. So we need to use 1 and divide by the total relative abundance of the 3 isotopes and divide it by 100. So the answer is 0.07. And lastly, we need to calculate the percentage of abundance for argon-40. So we just do the same method and we can get the answer 99.59%. So now let us move on to the second question. So the question asking us to calculate the relative atomic mass of argon to 4 significant figures. So first we need to identify which formula that we need to use in this question. So since they are asking us the relative atomic mass of an argon, first we need to use the average atomic mass formula. So we need to calculate the average atomic mass of argon. The first one is argon-36 times with the relative abundance, which is 4.86. So 4.86, how we get this is by the question that the first question just now, from the ratio that the question has given us. So we just apply to the formula and then we can get the answer 39.98 with the unit AMU. But the question asking us relative atomic mass. So as we all know, relative atomic mass does not have any unit. So what we have to do is the answer for the average atomic mass need to be divided by 1/12 times with 12 AMU. The answer for relative atomic mass of argon is 39.98 only without the unit. Now, let us see question B. A solution is prepared by dissolving 10 cm³ of ethanol in 1 kg of water and resulting 100 cm³ solution. The density of ethanol is 0.789 gram cm³ and determine the first question. They're asking us to determine the mole fraction of ethanol. So if you get this kind of question, first you need to identify the info and highlight the info that they have given us in the question. First, you must highlight solution, and it dissolves in 10 cm³ of ethanol. So from here, from the keyword that they have given us here, we can know that ethanol is solute and 1 kg of water resulting is 100 cm³ of solution. So this is the solution and the density of ethanol. Density of the solute is 0.789. We need to apply the formula of density of solute. So in this question, the solute is being used is ethanol. So we need to use the density of solute, which is ethanol, equal to mass of solute over volume of solution for us, in order for us to know the mass of the solute. The mass of the solute is 78.9 gram. So this is the mass of the ethanol. So when we already know the mass of the solute, which is ethanol, now we can calculate or identify the number of moles of ethanol. Number of moles of ethanol, which is 0.1715 mole. And now we can determine the number of moles for water, since they already given to us the mass of the water is 1 kg. So we can already know how to calculate the number of moles of water, which is 1 kg just now. We need to convert it to 1000 gram and then divided by relative atomic mass of H2O, which is 2 plus 16. And then we can get the number of mole of water, which is 55.56 mole. We are now able to calculate the mole fraction of ethanol. So first we need to know what is the formula for mole fraction. Number of mole of ethanol divided by number of mole for the total, which is the solute plus solvent. So the solute here is ethanol and then the solvent here is water. So the number of mole of ethanol we already calculate just now, which is 0.175 divided by the total number of mole, which is solute plus solvent. So solute here is ethanol plus with the number of mole of water. And then we can get the answer for mole fraction of ethanol is 3.077 times 10 to the power of negative 3. First question is, determine the limiting reagent in the reaction. First and foremost, in this question, we must calculate the number of mole for both element, which is in this case is sulfuric acid and also aluminium. The mass of aluminium it has given to us in the question, which is 20 gram of aluminium. And then what we must do is calculate the number of mole of aluminium, the mass of aluminium divided by the relative atomic mass, and we can get the number of mole given for aluminium. Same goes to number of mole sulfuric acid. We use the mass in the question. It has given to us 115.0 gram sulfuric acid, and then divided by the relative atomic mass of sulfuric acid, and then we can get the number of mole given for sulfuric acid. So now we can compare. So how we're going to compare is by using the formula, by using the equation that it has given to us, which is 2 mole of aluminium react with 3 mole of sulfuric acid. So from the equation, 2 mole of aluminium react with 3 mole of sulfuric acid. So 0.7407 mole of Al from the calculation that we did just now, times with 3 mole of sulfuric acid and divided by 2 mole of aluminium. And then we can get the number of mole for H2SO4 used. So now, as we can see, the number of mole given for the sulfuric acid is more than the number of mole used for sulfuric acid. Now we can know that sulfuric acid is the excess reagent in this case. But the question is asking us to find the limiting reagent. So automatically we can know that when one of the element is the excess reactant, and obviously we can know that the other element is the limiting reagent. So now we can know that the excess reagent is sulfuric acid, while the limiting reagent is aluminium. Now let's move on to the next question. Calculate the mass of aluminium sulfate produced. We need to compare once again by using the equation. But this time we need to compare with the limiting reactant and the element that the question asked, which is in this case is aluminium sulfate. So we already know from the previous question the limiting reactant is aluminium. So we need to compare with aluminium. 2 mole of aluminium react with 1 mole of aluminium sulfate. From the equation just now, 2 mole of aluminium react with 1 mole of aluminium sulfate. And then so this is the mole that we already counted just now, which is the number of mole given of aluminium divided by 2, which is the number of mole of aluminium, and times with 1 mole, which is the number of mole of aluminium sulfate, and we can get the number of mole for aluminium sulfate. Why we need to determine the number of mole of aluminium sulfate? So number of mole times with relative atomic mass of aluminium sulfate, we can get the mass of aluminium sulfate, which is 126.79 gram. Now the last question, calculate the mass of excess reagent remain at the end of the reaction. So as we do the calculation, we already know that the mass of the excess reactant in this case is sulfuric acid. So we already did the calculation from the first question just now, and then we already identified the excess reagent, right? So in this case, the mass of excess reagent is actually the mass of excess of sulfuric acid. So we do the calculation just like the first calculation that we did just now, and then we can get the number of mole of excess reagent, which is sulfuric acid, 1.11 mole. So this is the number of mole used. Now we need to calculate the mole of excess reagent, which is sulfuric acid. So how we need to calculate is mole given of sulfuric acid minus by the mole used of sulfuric acid. So mole given that we have calculated in the first question, which is this one. So this is the mole given for sulfuric acid, and then we have to minus by the mole used for sulfuric acid, which is 1.11 mole. So here is the calculation, and then we can get the number of mole of excess sulfuric acid, which is 0.0613 mole. So now when we know the number of mole of excess sulfuric acid, we can calculate the mass of excess sulfuric acid by multiply the number of mole by relative atomic mass of sulfuric acid, and then we can get the mass of excess reagent, which is mass of excess sulfuric acid, which is 6.01 gram. That's all from me. Thank you for watching.